All right, we're in section 1.6 where we're going to classify polygons. So first off, we have to be able to identify polygons. In geometry, a figure that lies in a plane is called a plane figure, and a polygon, by definition, is a closed figure which has the following properties. First, it forms by three or more line segments, which are called sides. So anything that has three or more line segments are called sides. And each side intersects exactly two sides at each endpoint, so that no two sides with common endpoints are collinear. So, we have this kind of a shape here. All of those line segments share endpoints, and none of the endpoints are collinear. Okay. Each endpoint of a side is a vertex, so kind of like what we talked about with angles um, in 1.4, and the plural term for vertex are called vertices. So anytime we're trying to look at polygons, there's some things that we have to keep in mind. Uh, what doesn't constitute a polygon? I would say there's about three things. All right, there's three things that we can have. First, uh, in order for it to be a polygon, you can't have any curves, so no curves. So if you have like this kind of shape, that's not a polygon. Second thing is you can't have any intersection in the interior. So if you had this kind of shape like this, and then you had another shape, and then you had another line like this, that can't happen. And then the last thing here, it says it's got to have a all closed section. So you can't have something like this and have a stopping point. Okay. It says polygon can be named by listing the vertices in consecutive order. Okay, so for example, uh, so like this is a pentagon, a five-sided figure. You could say pentagon A, B, C, D, E, or you could change up the order C, D, E, A, B. Both are correct for naming the polygon below. There are two types of polygons. The first one is a convex polygon. The other is a concave. So we got convex and we got concave. So convex polygons, it says if no line that contains a side of a polygon contains a point in the interior of the polygon. So what I usually show is this. I usually take a straight edge and what we're going to do is you're going to look at each line segment in the polygon. So from here, if you look at this ruler is touching line segment ED. Now that I realize that line segment AD is not, this ruler is not touching the interior, that means that for this part, for at least for this initial part, we're okay with um, it being, it could be convex. So now I go over here and I look at the next one, which is CD. I come over here. It's not intersecting the interior. So I go to the next one. I go to BC. Same thing. Go around. Good. Got AB. Good. And then the last one, AE. And you have to do it to every single side. If once every single side is shown that the ruler never went into the interior of that polygon, we can say that it is convex. So in this particular example, I could say that A, B, C, D, E is convex. Okay. For it to be a concave polygon, it says if it's not convex. So like, let's say I had a shape like this. All right. So all you have to find is one. So, and the one that goes through the interior is like, say, like this line right here. If you notice, oh, it goes through the interior right here. Since it goes through the interior, this would be an example of a concave polygon. All right. If you look here, it says an n-gon is a polygon with n number of sides. So if it was, usually they get denoted with names that are like larger than, like 14 or 15 sides. So if you had like a 20-sided figure, you'd call that a 20-gon. Uh, Polynomials that are equilateral are polygons that sides are congruent. Polygons that are equiangular are polygons that have all interior angles that are congruent. You can have polygons that are both equilateral and equiangular. They have a very specific name, and they are called regular polygons. That means that all the sides are congruent and all the interior angles are congruent as well. So that means that in order for a polygon to be a regular polygon, it must be convex. So here, they want us to tell whether the polygon, tell whether it is a polygon, and if it is, they want to know if it's convex or concave. So if it's not, we just say it's not a polygon. If it is a polygon, they want you to illustrate if it's convex or concave. So if you look at the first one here, so let's call this like A. Looking at this first one here, this one is not a polygon. The reasoning would be intersection of the interior. The next one is a polygon, all right? So there, again, it's a closed plane, all line segments, no intersection, no lines in the interior. Okay, so yes, this is a polygon. And again, if I looked at my ruler, I can even just draw here like, oh, no crossing in the interior, no crossing in the interior, nope, nope, nope. So because all of those lines, you could use a ruler too, this would now be convex. The next one, yes, this is also a polygon. And if I were to take a straight edge here, my straight edge would cross the interior at that point. I only need to find the one, and that's concave. This one here, again, let's call this B. We'll call this one C. This one is part D. All right, polygon. Yes, it is. All right, got to determine if it's convex or concave. I got edge here. Nope, 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 and nope. So it worked for all the sides here. So there was no intersection of the interior. Convex. And then the last one is I have this curvature here. Can't you have a curve? So not a polygon. And I'm just going to put curve right there. Here it says classify the polygon by the number of sides. Tell whether if it's equal equilateral, equal angular, or regular. So looking at this one here, let's call it A. This has got 1, 2, 3, 4, 5, 6, 7, 8 sides. So if it's an 8-sided figure, it's an octagon. And does it have all equal sides? So, whoops, sides are congruent because of the hash marks. Are angles congruent? Yes, they are. Angles congruent. So both of them are there. So that means that it is regular. Now, the picture on the right, part B, will say, the question they ask is classify the number of sides. So this is 1, 2, 3, 4. We can say that this is a quadrilateral. And do they have all sides congruent? The answer would be no. So it's not equilateral. Are the um, angles congruent? I got 2 markings here, 2 markings here, 1 and 1. So they're all not congruent. So, but you know, 2 sets are and 2 sets are, but so in this case, no. So it's not an equal side. It's not um, equal angles. So that means it's not regular. So it would be neither equal angular or equilateral. All right. So here it says the head of a bolt is shaped like a regular hexagon. The expression shown represents side lengths of a hexagonal bolt. Find the length of the sides. So it's telling you that it's regular. So because they said it in the problem, that means that all the sides are congruent and all the angles are congruent as well. So because of that, 4x plus 3 is going to be equal to 5x minus 1. So we set them equal to each other. Subtract 4x from both sides. I'm going to add 1 to both sides. This cancels. This cancels. I'm left with 4 equals x. But they want us to find the length of the sides, so we plug 4 in for x. It actually does not matter which one you choose. So if I went with the top one, so I got 4 times 4 plus 3. 4 times 4 is 16. 16 plus 3 is 19. So it's going to be 19 millimeters. If I use the other one, 4, 5 times 4 is 20. 20 minus 1 is 19. You get the same answer. On the bottom, this says the expression 4x plus 8 degrees and 5x minus 5 degrees represent the measure of 2 congruent interior angles of that hexagonal bolt above. They want you to find the measure of that. So same thing. Because they said it was a regular polygon, we can set 4x plus 8 and 5x minus 5 equal to each other. And then so we just do the same thing. We subtract 4x. We're going to add 5 to both sides. This, oh, I'm sorry, this doesn't get canceled. This gets canceled. This just turns to x. This would get canceled, and it would become 13. But again, you just have to plug it into any one of these two. And let's say I plug it in with the first one, 4 times it by 13 plus 8. 4 times 13 is 52. 52 plus 8 is 60 degrees. And it would work for the other one. So if I went 5 times 13, that's 65. 65 minus 5 is also 60. And that is being able to classify polygons. Hope this helps. Till next time.